Okay, now we will be discussing monochrome minimization. So in this question we are given n plus m points, where n points will lie on x-axis and m points will lie on x-axis, and we need to color these n plus m points with either red color or with the blue color. Okay, and we have to color these points in such a way that if you have a coordinate plane where this coordinate plane will contain m points on x-axis and there will be m points on y-axis. Okay, now we have to color in such a way that at least one red should be there on x-axis and there should be at least one blue on x-axis. In a similar way, one red should be there on y-axis, one blue should be there on y-axis. It means from n points, one red, one blue should be there, and rest n minus 2 can be any color. And from m colors, one red, one blue, and rest m minus 2 can be of any color. Okay, now keeping these things in mind, we need to find a monochromatic number. What is monochromatic number? Monochromatic is number is nothing but the maximum area that will be formed. Monochromatic number is the maximum area that will be formed by selecting any three points of same color on this coordinate plane. So let's say we have a coordinate plane. Now we need to select 3 points on this coordinate plane. That is, let's say I am selecting 2 points from the x-axis, and this is, let's say, x1 and x2. And if I want to form a valid triangle, then the third point needs to be selected from the y-axis. So I will select it from the y-axis. Let's say y1. Now 3 points that I have selected here should be of same color. Now the area that formed with this triangle will be this. This will be the triangle that will be formed with the x1, x2 and y1. Now monochromatic is number is nothing but the maximum area that will be formed with these 3 points. And our task is to find minimum possible monochromatic number across all possible coloring. So we need to color it in multiple ways, and we need to find all the monochromatic numbers. Among all monochromatic numbers, we need to find the minimum possible monochromatic number. Okay, so let's continue our discussions further. So before that, we first need to understand how do we find the area of the triangle. Okay, if you have 3 points x1, x2 and y1, then the area of a triangle is nothing but the base into height, half base into height. Okay, now here what is the base? Base is this length. So what is this length? x2 minus x1. So it will be half x2 minus x1 into what is my height? This is my height, which is y1. Then area will be half x2 minus x1 into y1. So this is my area of the triangle. Now I can select 2 red points on y-axis also and 1 point on x-axis also. Yes, in that case what will be my area? My area will be half. Now my y is changing, y2 minus y1 into x1. So this, or x1 or x2, anything, x2. This will be my area if I choose 2 points on the y-axis and 1 point on the x-axis. Now as we want to maximize the area that is formed, let's take the first case only, and if you are able to understand with the first case, then it is similar for the second case because it is a symmetrical triangle. Now the area which is half x2 minus x1 into y, or you can say y2, anything is okay. Let's say if this is y2, then if you see here the area is directly proportional to y2, and the area is also directly proportional to x2 minus x1. Yes, now if I want to maximize this area, I can increase my y2, I can increase the x2 minus x1. Yes, now if I want to increase my y2, then I need to choose a point on y-axis which is the farthest point, or which is the maximum point. Okay, now it means if I'm choosing the maximum point, then above this point there will no red point. Now I'm choosing only the red points. Now if I'm choosing one point which is the farthest, then it means the above of y2 there will be no red point. Yes, so this is the maximum y2. Now in a similar way, if I want to maximize this difference, now can I say I need to choose this x which is least, and can I say I have to choose this x2 which is greatest? Yes, now it means if I'm choosing the least x1 and if I'm choosing the greatest x2, then it means to the left of x1 there will be no red point. Yes, now in a similar way, to the right of x2 there will be no red point. Yes, if I'm choosing 2 points x1 and x2, which means which x is the least point and x2 is the greatest point, then I can surely say to the left of x1 there will be no red point now. Now in a similar way, there will be no red point to the right of x2. There can be a blue points, but there will be no red point. Yes, now it means all red points will lie here, and then you can have some blue over here, or you can either have blue over here. The blue can be either on the any of these sides, either here or here, but red will always lie from this x1 and x2 no matter what. Yes, now if the red lies in this area, can I say these points are continuous? All the red points are continuous. It means this is red r1, r2, r3, r4, so on and rn. Yes, now in a similar way, I can also choose 2 red points on my y-axis. Then this will be y1, y2, y3, so on and yn. Then this needs to be also continuous, because if this y, let's say if this is yn and this is the farthest point, then there will be no red point to the great higher than that. Then all red will definitely lie in this range. Now if I have something like this, y1, y2, y3, so on, yn, then all this will be red points. And so either you can have blue points over here, or you can have blue points over here. Okay, now we understood that to get the maximum area, the points need to be continuous. Yes, all red points need to be continuous. This does not apply for only the red color. This also applies for blue colors as well, because if I choose continuous r1 over here, r2 over here, r3 over here, and so on, rn over here, now I can't choose b1 here, b2 here, b3 here, and b4 here, b5 here, and so on, bn here. I can't split blues to both sides as well, because as I want to maximize the triangle area, which is the monochromatic number, I can get a triangle over with this point. Sorry, if my axis is somewhere here, I can now if I have an axis something like this, now if I'm trying to build, let me call as this b1, b2, and B3 somewhere here. Okay, now if I trying to maximize the area with blues, then I can, with selecting B1 over here and last B5 Bn over here, I can get the maximum area with the blues. But what about reds? Am I increasing the area of reds? If my red over is here, will I increase the area of red? No, I can't increase. Okay, as I want to increase the area for both the triangles form, which is a monochromatic number, then I should not take blues somewhere, blues some here and blues here, or else I can't take red, blue, and then red. This, or blue, or red, and blue. These two cases will not be valid because I want to maximize both the areas with the reds and as well as with blues. So I can't choose something like this. So what I can choose is, either I can choose blue, which is continuous, and then I can choose red, or else I can choose red, and I can choose blue. This should be valid for both x and y axis. Okay, so the points which I'm taking both on x and y axis needs to be continuous with red and blues. Okay, now with these things we will be able to get a triangles something like this. Now if I have continuous blues over x axis and then reds, and continuous blues first and then reds, I may get this area. If I choose two blue points over here and one red, one blue over here, then I will get a area which is this point. Or else if I choose two blues over here and one red, one blue over here, or else I will get this triangle. So I can either get this triangle, or else I can get this triangle if I'm choosing blue. Now if I choose red over here, if I choose two red over here and one red over here, then I can get this as the area. Or else if I choose two red over x axis and one red over y axis, then I can get a triangle which is something like this. Yes, in a similar way, if I change the ordering in the y axis, then if I choose two red over here and one red over here, then I can get a area this. Or else if I choose two red over x axis and one red over y axis, then I can get a area something like this. And this is true for blue also. If I choose two blues over x axis and one blue over y axis, then this will be my area. Or else if I choose two blues over here and one blue over x axis, then I will get a area something like this. Okay, it means from here we are getting four cases, and if I in these two diagrams I just changed the y axis, that's it. Initially I kept blue over here and then red, but here I kept red and blue. Now if I and my x, both the values are same. First I have blue and then I have blue and then I have red and red. Now if I try to change this direction, first over red and then blue, then I will get something like this. Okay, I will get something like this. Then this is nothing but the whatever the area that we are getting here, will be covered somewhere here, which is true. We can re-verify it. Okay, now here we have we are getting something like this, then that area will get here. Okay, now in a similar way, for all the values that we get here will be somewhere will be occurring in these two diagrams itself. So there is no need to change the pattern of colors in the x-axis. So the only thing, so we from now with all this observation, we found that the coloring needs to be continuous for both blue as well as for red. Now these blues and red can be like, we can choose any 2 points either from the x-axis or from the y-axis, and then we can try to form the triangle area. Now if I have few n number of points, okay, if I have m number of points, then in this n number of points I can choose one red and rest all as blue, and then I can try 2 reds, then I can try 3 reds, then I can try 4 reds, and so on till n-1 reds, and the rest will be opposite of that. Now if I have somewhere, like if my ith point I have blues, and till then if I have red points, then we can easily get the area of this triangle using the formula that we have discussed above that, which is x2 minus x1 into y1. So if my points, if till this point if I have blues and then I have red, then the area of the first triangle, if I try to find the area of this triangle, then it will be half bn minus b1 into bn, which is, this is x. If I write it in a more clear way, let's take this one and let's try to write the formula for it. Now if I'm considering this triangle area, then it will be half Rn minus R1, this is xr1 into yrn. Okay, this will be the first triangle area. Then the second triangle area can be these 3 points, then half x bn minus x b1 into ybn. Now in a similar way, these are the 2 triangles. Then we still have 2 points on x, 2 points on y-axis. Now with y points, we'll get y bn minus y b1 into xbn. Yes. Now if we still have one more point with the red, then it will be half yrn minus yr1 into xrn. So these are the 4 triangles that we get with this diagram, or you can say with this diagram. Okay, and in a similar way we'll get 4 more different areas with this diagram. Then the maximum of this one first pattern and the maximum of this pattern, the maximum of all these patterns will be our monochromatic number. Let's say if this is monochromatic number 1, and then we'll get monochromatic number 2 with this triangle, and then minimum of all this will be our answer. Okay, now as we have two arrays of x points and y points. We can sort the array and then we can iterate, and we can take first one number of point on y-axis, then two number of points on y-axis, 3 4, and then we can try all possible cases. Then we can able to get m minus 1 into n minus 1 number of total pairs, and then we can calculate this area. Okay, I hope you understood this problem. Thank you.